Alright, longest univalue path. This is a great problem. A lot of things to learn from this if you are new to tree problems, right? Let me take the pen out. Basically, the problem states that we are given a tree and we want the longest path which has the same value, and this path may not be from root. It usually we are given problems like from root to leaf, that is one path, but there is no path mentioned. It can be from any direction to any direction, but just it should be a straight path. So here we have 1, 2. This is a straight path, and I mean in terms of straight path it can go like this as well. For example, in the second example, 4 goes from here to here. So if you could think of edge cases, then that will be what? Suppose if we have a null node, the root itself is null. In that case, let's find out. Yeah, there is a scenario where the root itself is null. In that case, the value, the length should be 0. Alright, so we need to take care of that. How we are going to solve this? Since things can go only 3 ways, like this, or just like this, right? That's it. This will cover all 3 ways. If you would tell me that it doesn't cover this, but it does, right? I'm doing this for the entire tree. I'll be doing this recursively, so I'll have to keep track of these 3 things, right? If I am at a node, what all values or information I would need from the left subtree and the right subtree? Well, that is a good question, and I would say that I need a value and a count, right? Similarly, from here I need a value and a count, right? So what I'll be sending up, I'll be sending up only the one of the two, whichever is the maximum. I'll send that up along with one added to it if this value is matching that path value. So if this is confusing, let's think of this way. So this will return 4, 1. This will return 4, 1. Right? So I'll see that from the left side I get this. So this will basically a pair value return. So I'll have a function which will return a pair value, and I'll just check for the value for the first. If the value is matching the current value, in that case this is a valid thing that I need to send above. Similarly, if this matches, then I'll have to send this above. If both matches, then we need to update the answer for managing this as well, right? How will we update? We'll add the count from this side and this side, and we'll add this one as well, and we'll update the answer. That's it. So if this is the path that is the maximum, by the end I'll have this only as the maximum answer in my variable that I will return. So that's how we are going to solve this. So I'll call function probably solve. I'll pass the node value, or actually the root, and I'll pass a value, right? So that I can keep track of it. Or actually I don't even need that value if I think of it now, because I'll be returning that value up, right? Let's see, let's right now have a value that I'll pass int max initially, and I'll return the answer, and I'll have answer here as I need the maximum, so initially it will be 0. That's fine. I will return a pair of boolean and actually I don't need this thing. A boolean and a integer. Fine. Okay. So this will be the this will be int, and this will be the value, and this will be the count. Alright. Solve. I will be passing the node. So I'll call it root here as well. If the root is null, in that case return a pair with count or the value as int max. Right. So if you look at the value, it can be from -1000 to 1000, so int max is fine, it's not going to interfere with my answer. And finally the count. Alright, so at this point I will call this for the left. We'll go pre-order, right? Pre-order traversal. So we'll go here, we'll go here, we'll go here, and as soon as we return, we'll return the value that the pair value which this node is looking for, and then we'll go to the right, or I think the good way to do is left, right, and then root. So I don't remember what traversal that is, but that's how you're going to solve it. So first I'll call the root left and the root right. I have this pair, store it in something like left pair. Similarly, the right pair. Finally, I'll check if the left pair first value, that is the value, if it's equal to the root value. In that case, I'll have something called a count variable for this node to have its count, right? So that I'll return that as a pair. So this will initially be 0, and I'll maximize it with this pair. I'll add 1 to it because this root value is equal, and I'll add the second element or the value inside this pair, which is the count. Similarly, I'll have it for the right pair. So this is the same thing. Now I'll have something for this scenario to be handled, right? So that I'll have the same condition but for both the pairs. So the left pair, if it's equal to the root value, and the right pair is also equal to the root value, in that case I'll update the answer. With what? The left pair. Basically these things and this. So I'll add up the 2 as well. So this will be 2 plus left pair second value, right pair second value. Otherwise I'll still update for the straight paths, right? That will be either of the right pair or the left pair, right? So it will be, that's basically my count. So I'll update the answer with the count, and now comes the part where we return the pair. That is nothing but the root value and the count. This is it. Let's see if this works. missing some semicolons. Thus, time complexity will be O of L since we are visiting each node only once, and space complexity will be O of 1 if you are not counting the stack space. So yeah, that's it. It's a good problem, and thanks guys.